Hello guys and welcome back to the Physics and Maths blog. Today we're going to go over our next video in our series on abstract algebra. We're going to be continuing complex numbers and doing some questions today. So these are just to help you understand complex numbers a bit more. So let's get into this. Write the following expressions in the form a plus bi for a and b to both be real numbers. So we have 1 to 4 here. Those are some questions. We have I to the cubed, we have I to the 23, we have 4 minus I times 5 plus 3i, and we have 2 minus 3i times 4 plus I plus 6 minus 5i. So pause, have a go, and then we'll get back to it. So I hope you've had a go at them. Let's go through them. So I cubed in the form just gives you minus I. We don't have an a value here because there's no real number, but our imaginary, for b we have minus 1. So we have I times I, which gives you minus 1, and then times I again gives you minus I. For I to the 23rd, we have minus I as well. So the way to do this is, if we do think about I itself and we times against each other, which will be I squared, we get minus 1. And we times I again, we get minus I. And then we times it by I again, we get to 1. So then you see that we get I minus 1 minus I 1. Then it's times by 1 again to get I to the 5, we get back to I. So this is kind of a pattern here every 4. So what you can kind of do is you can get a number like 23, find a number that's divisible by 4, so the 20 part of it divisible by 4, and you know that that value gives you back to I itself. So then essentially it breaks down to I cubed. So that's why we get minus I. I hope that made sense. Moving on to our multiplication with real numbers in it, we have 4 minus I times 5 plus 3i, and that gives you 23 plus 7i. So you get the 4 times 5 to give you 20. You get the minus I times 3i to get you the minus 3i squared, which comes into 3. So you get the 23 plus onto the 20, and then you get the minus 5i and the plus 12i to get you the 7i on the end. And then for our final one, we get the value of 17 minus 15i or plus negative 15i. Moving on to our next set of questions, we have write the following complex numbers in polar form, where we have the modulus or the absolute value of our complex number times p plus qi, where p plus qi equals 1. So we have minus 1 plus I. Think about, the way I'd suggest doing this is think about a and b here. So what is a and what is b? And then we're going to use the form of the square root of a squared plus b squared. And we're also going to do the same for minus 3 plus 5i. So for our first, pause this, have a go, and we'll go back to it. Sorry, I jumped ahead there. So for our first one, we have minus 1 squared plus 1 squared, not I squared, because 1 is our b value here. So that gives you 2, and then we get the square root to get your z in absolute value form. So we have square root, and then we want our p plus qi, which is our minus 1 plus I, to equal 1. So that means that we have to divide by square root of 2 on both of them to get our final answer of this. Applying what we've just done to our second one, we have to do minus 3 squared plus 5 squared, which gives you 9 squared plus 25. Which gives you 9 plus 25, which is 34, and you've got square root that, which gives you square root of 34. And doing what we did with the middle, we're just going to divide through that. So we get square root of 34 times minus 3 over the square root of 34 plus 5 over the square root of 34 times I. Thank you for watching. I hope that kind of helped with your complex number understanding. Make sure you follow this series, our Abstract Algebra Series, for more content, examples and proof. Hit like and subscribe, and I'll see you guys in the next video. Goodbye.